Students, today we are going to start with circles, which is a part of geometry. It is an extremely important topic as it carries 20% weightage in our quant portion of CAT exam. So let's get started with the properties and theorems of circles. Now you are already aware of these important terms, but let's just quickly go through all of them. Alright, so the first one is a line segment joining two distinct points on the circle is known as a chord. We know that a line joining two distinct points on the circle, that is the line AB, is a chord. Alright. Now second is a line which touches the circle at only one point is known as a tangent. The line AB here, which is touching only a point on the circle, is known as a tangent. Third, a line which passes through two distinct points on a circle is known as a secant. So a point A, alright, and the line starts from A, passes the circle at two distinct points. Now this line is known as a secant. This line is known as a secant. Fourth is arc is a part of the circle. So this whole area, this whole circumference is a part of arc, right? Or arc is a part of this circumference. When we take 2 points on the circumference of the circle, alright, when we take 2 points on the circumference of the circle, we can have 2 arcs. So we have 2 arcs. One is this one and the other is this one, alright. So one is the major arc and the other is the minor arc. One is the minor arc. And the measurement of arc, that is the measurement of this arc, that is theta, is the angle made by the end points of the arc at the center. Alright. So it is the angle made by the arc by the end points of at the center. Alright. So length of the arc. So you can say the length of the arc is equal to pi by 360 into 2 pi r. Moving on to the next one, the part of a circle that is enclosed by an arc. Alright, now here you are talking about just the circumference, just the arc. So this is which is enclosed by an arc, this inner portion. Alright, so this inner portion we are talking about, this is known as a sector, either this one or this one. It is enclosed by an arc. Now, if the arc of the sector is a minor arc, we know that this is minor, the smaller one is minor. So, the sector will be called a minor sector. And if the arc is a major arc, alright, then the sector is the major sector. I hope these 3 are clear. Moving on to the last one, the angle made by diameter at a point. So, AB is the diameter of the circle and O is the center of the circle. Alright. So, if the angle is on the circumference, alright, this circumference, then it is 90 degrees. Then it is 90 degrees. If it is outside the circle, if it is starting from the diameter but it is outside the circle, then it is greater than 90 degrees. Alright, and if it is inside the circle, then it is smaller than 90 degrees. So these are some basic concepts, basic terms you should know before starting from the basics of circles, right? So let's just start with the first property of circles, which says that a line passing through touching any point, any one point of the circle externally is called tangent. Radius and tangent forms an angle of 90 degree. Now we have already done what is a tangent. We understood it in the concepts, in the important terms, right? So this is the center O and this is the radius of the circle and this line AB is the tangent. AB is the tangent. You know that, right? So now the first property says that a line passing through touching one point of the circle externally is called tangent. We know what is a tangent. And the radius and tangent. The radius and tangent forms a 90-degree angle. So any tangent, a tangent can be drawn here. It can be drawn here. Sorry for my rough drawing, but it just touches the circle at one point. It touches the circle at one point. Like you can, if you draw a straight line like this, all right. So a tangent just touches the circle at one point only, and that forms a 90-degree angle. All right. I hope this is clear to you all. First property is clear, right? So moving on to the next property. It says from any external point only two tangents can be drawn and the tangents will be equal in length. Alright. So now let's say this is a point, A is the point outside the circle and two tangents are drawn. Alright. One is, let's say, AB, the other is AC. Two tangents are drawn. Now, can you tell me that can I draw a third tangent here? A tangent that joins the circle at a point. Alright. Can I draw a third tangent here? No, I cannot. I cannot, because from this point, from point A, only two tangents can be drawn. We cannot draw three tangents here. Right, so this is the second property, but it is a very important property. All right, and this figure is this type of figure, right? It is a very important figure in geometry. This is very important figure in geometry. So we'll focus a bit more on this figure, right? Now this is the figure, right? And we have the points A, B, C. Now this is the center O. This is line A. All right. This, the point where it is meeting, the line is meeting the circle, that this point is B and this point is C. Right. Now AB, this is the center O, and AB and AC are two tangents, right? Now AB is equal to AC. AB is equal to AC. Alright. So, this is the circle. Now, if I join BO and OC, BO and OC, I have joined BO and OC here, right? So, now what happens is BO is equal to OC or OB is equal to OC. All right. So can you see that this ABOC is a quadrilateral, ABOC? But can you tell me what kind of quadrilateral it is? Can you just see and tell that what shape it is making? ABOC is a kite. ABOC is a kite. Now, this is, as I told you, this is a very important figure in circles. So, we'll discuss the properties of kite here, right? Now, we know that this point was, if I just rotate this, so we know that O is the point here, right? So, I'll make O here, B, C and A. Alright, so I have magnified this figure here. Right. So, in a kite, the adjacent pair of sides are equal and the longer diagonal bisects the shorter one at 90 degrees. So, as we just read that OB is equal to OC and BA is equal to CA. We know that. Alright. So, in the property of kite, we know that the adjacent pairs of sides are equal. Right. And OA is a diagonal. OA is a diagonal and the other one is BC. BC is also a diagonal. So the longer diagonal, that is AO, the longer diagonal, that is AO, bisects the shorter one at 90 degrees. Bisects the shorter one at 90 degrees. So if it is bisecting, then it means This point, let's say it is D. Alright, the point where it is bisecting is D. So now we know BD is equal to DC. BD is equal to DC. So now we know OB is equal to OC, AB is equal to AC, and BD is also equal to DC, right? So we know the first property of kite. Secondly, it says that one pair of angle at vertices. Now the angles here, that is theta, or you can say x here. So this says that secondly, one pair of angle at vertices gets bisected. So this pair also gets bisected, right? So these are the properties of kite. So in the second property, we just read that only two tangents can be drawn from the outside point. Only two tangents can be drawn. And this figure becomes an important figure as it has the properties of circles as well as the properties of a quadrilateral, that is a kite. I hope this is clear to you all. Let's quickly move on to the third property, which is known as alternate segment theorem. The alternate segment theorem says that the angle between a tangent and a chord is equal to the angle in the alternate segment. So we just understood when we did the important terms that what is a tangent. So if we say AB here, so AB is a tangent. It is touching the circle at this point, right? A chord, let's say CD here is a chord. CD is a chord. Now it says it is equal to the angle in the alternate segment. Now alternate segment. So this is one segment of the circle and this is the other segment of the circle. So it says if one angle is in the alternate segment, like if for example, if it is a hair, then it will be equal to the angle in the other segment, in the second segment. How? So now have a look here. If I draw a chord here, right? So what angle will this make? This will make a angle here theta, right? So this chord will make angle here theta. Now this is the minor segment and this is the major segment. Now here I can draw multiple angles here. First, second like this, third one here. And these all will be equal. These all will be equal, that is theta, right? So these all will be equal, that is theta. Now if we talk here, right? So we had a chord here, right? CD is the chord, AB is the tangent. If I make angle here, if I make an angle here, it is in the minor segment. So the other angle which is equal to that angle will be in the other segment, that is here and is here. So if this is x, this will also be x. This will also be x. Similarly, if I draw an angle here with this tangent and here, so the other angle, this one is in the major segment. So the other angle would be in the minor segment, that is here, and the angle would be here. So if this is theta, this will also be theta. So this will also be theta. I hope this is understood. Alright, so this is the minor segment. If I draw it in the minor segment, the other one here in the major segment will be equal to that angle. Similarly, if I draw it in the major segment, it will be equal to the one in the minor segment. So now I have drawn two angles here, one x here and one theta here. One x and one theta. Can we say that theta plus x is equal to 180 degrees? Is equal to 180 degrees? Yes, because on a straight line, this whole angle will be equal to 180 degrees. So theta plus x is equal to 180 degrees. Right? Understood to you all? Moving on to the fourth property that says that the opposite angles in a cyclic quadrilateral are supplementary. So can you see here when we were talking about the opposite angles here, right? So see, let's say we mark this as E, D and F. So CEDF makes a cyclic quadrilateral here. CEDF. So this is a cyclic quadrilateral. All right. Now this angle and this angle. We are talking about these two angles, angle at F and angle at E. If this angle is X, then this angle will be 180 minus X. So what is this property? This property says that the opposite angles in a cyclic quadrilateral are supplementary. That means the total of X plus this angle is equal to 180 degrees. All right. So the sum of opposite angles, this means that the sum of opposite angles is equal to 180 degrees. So if one is X, the other one would be 180 minus X. Right. And if we talk about the area of a cyclic quadrilateral, what is it? It is area is equal to under root of S minus A into S minus B into S minus C into S minus D. Or you can say, what is ABCD here? Right? You can say that this length is A, this length is B, this length is C and this length is D. So A, B, C, D, these are the lengths of the cyclic quadrilateral. So the area of a cyclic quadrilateral is under root of S minus A, S minus B, S minus C and S minus D. Right? So now what is S? S is the perimeter of the whole cyclic quadrilateral. S is the perimeter of the whole cyclic quadrilateral, which is equal to A plus B plus C plus D whole divided by 2. So this is the perimeter, all right, and this is the area of the cyclic quadrilateral. So we are now clear with the fourth property, that is the opposite angles in a cyclic quadrilateral are supplementary. That means the opposite angles, let me just tell you once again that this angle, right, so angle at C here and the angle at D here, right? So the first angle C, that is X, plus the angle at D here, that is, let's say, theta. All right. So X plus theta is equal to 180 degrees. So, but if we know only X, we know the value of X. So theta would be 180 minus X, right? And we also learned about the area of a cyclic quadrilateral, also how to calculate the perimeter of the cyclic quadrilateral. All right. So the Ptolemy's theorem, all right, the Ptolemy's theorem is also related to the cyclic quadrilateral. This is related to this property only, that it says that in a cyclic quadrilateral, the product of diagonals is equal to sum of product of opposite sides. All right. So now this is a cyclic quadrilateral, right? Let me just mark it A, B, C, D. So this is a cyclic quadrilateral. All right, and it has two diagonals, that is DB and AC. Two diagonals, DB and AC. So this is a cyclic quadrilateral, that is ABCD, and two diagonals we have, that is DB and AC. Right? Now the Ptolemy's theorem, the P is silent here. Ptolemy's theorem says that in a cyclic quadrilateral, that is A, B, C, D, the product of diagonals, which means AC into DB is equal to the sum of product of opposite sides. That means the product of opposite sides, that is AB into DC plus AD into the other side, that is BC. So by the Ptolemy's theorem, what we say is that the opposite sides, that is the diagonals, that is AC is a diagonal and DB is also a diagonal, right? These are the two diagonals. So the product of these diagonals is equal to the sum of product of opposite sides. The opposite sides would be AB and DC. All right. So AB into DC plus AD into BC. Right. So this is how we calculate the product of diagonals. And now we know about the cyclic quadrilateral also, that in a cyclic quadrilateral the opposite angles are supplementary, and also about the Ptolemy's theorem, right? So what is the fifth property? Fifth property says that the measure of angle subtended to any point at the center from an arc is double to the angle made on the circumference of the circle by the same arc. Now we just talked about that the angles in the major segment, right? If I make an angle here, another angle here, all right? So if this angle is theta, what would be this angle? This would be also theta, all right? If I draw an angle in the minor segment, so this would be x. If I draw another angle here, what will be the value of this angle now? This will also be x. And if we talk about the cyclic quadrilateral, let's say A, B, C, D. So A, B, C, D is this. A, B. So this becomes a cyclic quadrilateral. And in a cyclic quadrilateral, the opposite angles are supplementary. That means x plus theta is equal to 180 degrees. Right? Now, what does this property say? This property says that if I make an angle at the center, this is the center of the circle. If I make an angle here and the other angles at the circumference, one at the center and other at the circumference of the circle. So if this is theta, this will also be theta. And what will be the value of this angle? This angle would be 2 theta. This is what property 5 says. What does it say? That the measures of angles subtended to any point at the center from an arc. This is the arc AB. Alright. So if it is at the center, then it is double the angle made on the circumference of the circle. These angles are at the circumference of the circle, right? So this angle at the center O would be 2 theta. That is double the angle made, right? Clear? We are done with fifth property, right? Let's see the sixth property, which is a very simple one. So what does this property says? This property says that the angles made by the diameter is always 60 degree. Now diameter is the longest chord. It is the longest chord. Alright. So if this is the center, then this is the diameter, and you can make another diameter here. Alright. So this would also be the diameter, right? So these are the diameters. Now the angles made by the diameter. We are not talking about anywhere here. This is a chord, but this point, that is the diameter, that is AB if we talk about, then the angles made by the diameter is always 90 degrees. Do you make any angle from the diameter? You are making it here, right? Or let me just change the pen so that you can understand it. If I make an angle here, this would also be 90, right? Now we just said that this is also the diameter, this is passing from the center, right? This is also the diameter, and the angle made by this diameter would also be 90 degrees, right? So sixth property is a very simple one, that the angles made by the diameter is always 90 degrees, right? Let's move on to the seventh one. Now you have to pay a lot of attention from now onwards, because these properties or these theorems which we will be doing now, we'll discuss now, are very important. Also, what is your task? Your task is go to the EduRev app or website. All right, go look for the chapter wise notes there. You'll have detailed notes of circles there. Take the test there, and then you'll get to know what is your level right now. Also, we have provided that how do you have to prepare for your CAT exam. All right, so you can go look at that document and you'll get to know how you have to start with your preparations and move on with daily basis, right? So let's start with the seventh property. All right, so this property is related to chords. Now what does this property say? That two equal chords of circles subtend equal angles at the center of the circle. How? Now I have drawn two chords here, that is AB and CD. AB and CD, and this is the center, that is O. This is the center at O. Now if I drop two perpendiculars here, one here and the other one here, I have dropped two perpendiculars here. Can you tell me what is the property of a perpendicular? Now this means that this angle made by the perpendicular is 90 degrees. Also, this angle is 90 degrees. And the other property of perpendicular is that it bisects the line into two equal halves. Alright, so if I say that this is P and this is Q, so AP is equal to PB, is equal to PB. This is the property of the perpendicular, that it bisects the line into two equal halves. Alright, now if I talk about OQ also bisects CD into two equal halves. That means CQ is equal to QD. CQ is equal to QD. Now I just told you that I have made two equal chords. Two equal chords means that AB is equal to CD. AB is equal to CD. Alright, and we just said that if I drop two perpendiculars from point O, OP and OQ, this will bisect AB, which means that AP is equal to PB and CQ is equal to QD. CQ is equal to QD. If AB is equal to CD, then it means that the center, that from the center the lines AB and CD are equidistant. That means this line, that is OQ, is equal to OP. This line is equal to this. Why? Because from the center, this line and this line are equidistant, right? So this means that OQ is equal to OP. OQ is equal to OP, because from the center these two lines are equidistant. That means this length and this length is equal. And if I draw two angles here, from point O, I'll draw two angles. So if this is equal, this and this is equal, then the angles will also be equal. Then the angles will also be equal. That means x is equal to x, right? So this is what property 7 says, that two equal chords ABCD subtend equal angles at the center of the circle. So equal angles at the center of the circle, that means x and x will be equal. Alright, so this is the property 7. Let's move on to the property 8. So now property 8 of circles is related to the area of a sector. Do we know what is a sector? Yes, we have already discussed above that this portion is a sector of a circle. And do you guys know how to calculate the area of a circle? What is the formula to calculate the area of a circle? It is pi r square. It is pi r square. So if we know how to calculate the area of the whole circle, can we calculate the area of this sector? Yes, we can. And what is the formula? So it is theta by 360 into pi r square. So this angle is theta, right? So the area of a sector is equal to theta by 360 into pi r square. This is how we calculate the area of a sector. Let's move on to the 9th property, that is theta is the half of difference of the opposite arc angles. Let us understand this. So the property 9th, 10th and 11th. Alright, these properties are related to the secants, chords and tangents, right? Secant, chord and tangents. So carefully listen to the property 9th. Now, how do we know this? That theta is the half of difference of the opposite angles. So now, how do we prove this? Alright, so now let this point be O. This is A and this is B. Alright, C and D. Alright, so now this is point O and point O. And from point O, there are two secants, right? That is OA and OB. There are two secants, OA and OB. So, a single point from where two secants are crossing, alright. So, these two lines would be equal. OA is equal to OB. OA is equal to OB. Alright, because they are passing from the same point, alright, and these two will be equal. Right. The second point is that the angle at intersection, right, here at point O, that is theta. So the point here at theta, alright, so the theta is the angle at the intersection of OA and OB. Now, theta has two arcs in front of it. That is a minor arc, this one, CD, and a major arc, that is AB. And a major arc, AB. Now, if I draw two angles, like one from C, T, right, this angle, and if I draw one angle from A and here, this angle. So let this angle be X, the smaller one, and this angle be Y, the bigger one, right? So for theta, I have opposite two arcs, that is CD, which is X, and AB, which is Y, alright. So now theta would be, what would be the value of theta? Theta would be half of the difference between the opposite arc angles. Alright, the major one minus the minor one, right? So theta would be, and you'll be getting the questions like, if the value of x is, let's say, 25 degrees, y is 45 degrees. Calculate the value of theta. What will be the value of theta now? If I calculate, what will be the value of theta? Theta is equal to half of y is 45 degrees and x is 25 degrees. So it would be half of 45 minus 25 is 20, right? So this would be 10. So value of theta is 10 degrees. All right, understood this concept? So this is the ninth property, that is theta is the half of the difference of the opposite arc angles, right? So 10th property, which is also known as tangent secant theorem. Tangent secant theorem. So theta is the half of the difference of opposite arc angles. Here also. Now this one, let's say point O. Let's say point O is the point from where a secant, that is OA, a secant, that is OA, and a tangent, that is OB, is passing. That is OB is passing. Alright, and this is the center of the circle. So now, how do you calculate the angle theta here? How do we calculate this? Alright, so this is also similar to the first one only. And how do we calculate this? So from point O, let's say if I draw an angle from the secant, that is the point it is touching the arc, this point. So let's say this is the angle and the point from which it is touching the tangent, this point, right? So in front of O, I have two arcs. One arc here and the other arc here, this one, right? So this is the angle for this arc. Let's say this point is C. So AC, for AC, the arc AC, the angle is Y, and for let's say this is D. So DC arc, the angle is X. The angle is X, right? You have to be very careful because we are talking about two angles which are opposite to theta, So opposite to theta, we have two arcs, that is DC here and AC here. So for arc AC, the angle would be Y, angle Y here, right? And for DC, the angle would be X. So what will be the value of theta? Theta is also half of Y minus X, right? Here we were talking about two secants. Right? And here we are talking about a tangent and a secant. OB is a tangent and OA is a secant, right? Understood? So this is the last property for circles. And what does this say? That for chords intersecting inside the circle. Now we are talking about chords which are intersecting inside the circle. Let's say this is AB and this is CD. Alright, these two are chords and this is the point of center. Right? So this is the chord, this is the chord, and they are intersecting inside the circle, and this is the point of intersection, right? Let us say this is O. This is O. And we know if this is the point that is intersecting, then AO and AO into OB is equal to OC into OD, right? We know this, right? So now they say we are talking about theta here. So let's say the theta here is this. You can make any angle, right? So we are talking theta here, right? So this is theta. And you also know that the opposite angle, the angle opposite will also be theta, right? And if we talk about the arcs, right? So there are two arcs. One is BC, alright? So BC, and we'll make the angle for BC, which would be BC, this angle. So this angle is angle X. The other arc is DA. Alright, so we'll make the angle for DA, that would be this angle. Alright, for DA or AD arc, the angle would be angle Y. And for arc BC, this arc, the angle at the center would be X. So now inside the circle, when we talk about inside the circle, chords are intersecting inside the circle, then theta would be half of y plus x or x plus y. Alright, I hope this is clear to you all. So with this we come to the end of the properties and theorems of circles. So now you have to go to the EduRev app. Alright, you can check all the detailed notes there. Alright, the test for geometry, all the documents and videos. You can also unlock all the logged videos, documents and tests at less than ₹80 per month and ace your CAT exam. Thank you. I'll see you in the upcoming video where we will solve the practice questions related to circles.